Hello, ChemFam. Today we are going to discuss a very exam-oriented topic, that is prediction of period, group, block of a given element once you are given the atomic number of that element. All right. So the entire process is, once you have the atomic number, you need to write the electronic configuration. That is the main thing. Once you have the electronic configuration, it's just a matter of seconds to identify the period, block, and group of that element. So the core thing is writing the electronic configuration. So let's take one example. As we solve it, we will understand the entire process. All right. So today let's take atomic number 72. So let's try to identify the period, block, and group of an element with atomic number 72. So the first thing that we are going to do is we are going to write the electronic configuration of it. So for that, what all things you need to know, I'll just quickly write it on the board and explain it. Then we will write the electronic configuration, and then I will give you the the summary of how to identify the period, block, and group, and then we will get the answer to this question. All right. So the first thing is electronic configuration. So for that, okay. So what all you need to know? Suppose hydrogen, helium. Okay, so we need to know all the noble gases. So it is neon, argon, krypton, xenon, and radon. What are its atomic numbers? 10, 18, 36, 54, 56. And here it is the 118th element. Try to write its IUPAC name. You must be knowing it already, right? Okay, so corresponding to neon is the second period, isn't it? Third period, fourth period, fifth period, sixth period, seventh period. Okay, then I will write all the orbitals which are going to be filled along the second period, okay, as we proceed from left to right. Okay, so the orbitals which will be filled in the second period will be 2s and 2p. In case of third, it will be 3s and 3p. In case of fourth, it will be 4s, 3d, and 4p. In case of fifth period, it will be 5s, 4d, and 5p. In case of sixth, it will be 6s, 4f, 5d, and 6p. In case of sixth period, it will be 7s, 5f, 6d, and 7p. Now, how and why the order and all, it is based on the opt principle. All right. So if you need more clarity about it, maybe I can make a video, but then it comes from there. All right. The order of based on the order of energies, right? And the filling. All right. So now, okay, there's something extra that you need to know. In case of the sixth period, this is your group 1, you have group 2, and so on, and this is your 18th group. All right. So here your S subshell will be filling, and after that here, that will be here and here. Here's something you need to remember. Okay, so that will be like the third one, right? All right. So here, just remember, a slight difference will be there when atomic number 57 lanthanum comes. And the second one will be Z equals to 89 when actinium comes. So in case of lanthanum, what actually in this period happens is you fill the 6s, the 4fs, then 5d and 6p. That's the order, all right? But in case of lanthanum, after you fill 6s with 2 electrons, then instead of 4f, your 1 electron goes to 5d, and then after that, the 4f starts filling. So it will be like, it's lanthanum, right? So it will be xenon 54. It will be 5d1 6s2. We are not filling in 4f, but then after lanthanum or cerium and all that, you will start filling 4f. All right. Okay. The same thing happens in case of this one. What happens is will be radon 86. Okay. So here, what instead of 5f, the first the next electron, that is the 89th electron goes to 6d, 6d1, and sorry 7s2. And from the next atomic number onwards, the filling of the 5f starts. Okay. So remember these two cases. Whenever you get atomic number 57 and 89, be careful. All right. Okay. And also just remember that from atomic number 58 to 71, there's the lanthanide series, and from 90 to 103, it is the actinide series. Lanthanides and actinides. So just remember the range of the atomic numbers also. That will be a little more easier for you while writing the electronic configuration, identifying the location. I mean, like, just to make it more precise and easier for you. Okay. Okay, fine. So now let's just write the electronic configuration for an element with atomic number 72 using this data. All right. So it is 72. So what is the noble gas configuration just less than 72? It's 54. So that is the closed part that we will have. So it will be xenon 54. All right. Then you are going to fill from here. So this is the period under which it will belong, within which it will belong, right? So 54. So how many more electrons you need to fill? 72 minus 54. 18 more, right? So you will start filling from 6s. So okay, so since it's 72, it's neither lanthanide or lanthanum or actinium, right? So that thing is not there. So we can continue. There's no problem in filling based on the order, that is the general order. So after 54, the next electron, 55th, will enter 6s. We'll start filling it. So it will be 6s2, 4f, how many? 14. So how many are there? 16. One, so 2 more. 5d, 2. Is it correct now? Just check. Correct. So this is the electronic configuration of an element with atomic number 72. So let's just write it in a proper way. 54, so that the outermost shells are written outwards. All right. Okay. Now is the thing. How do we identify the period, block, and group? So I'll just quickly discuss that here, and then we will identify it for this particular element. Okay. So for period, it corresponds to the principal quantum number n of valence shell. All right. Then comes block. Block is corresponds to the type of orbital which receives the last electron. All right. Then group. Here you have three types, rather four. The first one, if it is s block element. So once you know the block, once it is, so for s block element, the group number will be equal to the number of valence electrons. For okay, I'll write it here. The group. For p block, it will be 10 plus number of electrons in valence shell. For d block, it will be number of electrons in n minus 1 d subshell plus number of valence, that is in n shell. Then last one, for f block, the group number will be 8. All right. So in our case, let's see what is its period, block, and group. Okay. So this is our electronic configuration. So the first thing for period, that is the n value for the valence shell. What is our valence shell? 6s. So what is the n value here? 6. So your period will be, right? Period will be 6. Then block. The last electron in this case entered 5d, right? We filled 6s, then 4f, and then 5d. So the last entered the 5d orbital. So the block will be d block. Then finally group. So this is a d block element, that is this case. So it is number of electrons in n minus d subshell. How many are there? 2 plus number of valence electrons. How many valence electrons? 2. So the period, the group is 4. So this is your answer. Period is 6. Okay, it belongs to d block, and the group number is 4. Okay. So try solving for, let's say, z equals to 84. Okay. So try solving it and match it with the periodic table. And if you are getting it right, that's it. You can solve any question based on this method. All right. So see you soon with the next video.